Okay, for the last problem, we have to calculate for the molar solubility and the pH of a saturated copper hydroxide solution, KSP, is 2.2 times 10 raised to negative 20. Okay, take note, since we're talking about molar solubility, copper hydroxide here is an insoluble substance. Okay, so how do insoluble substances dissociate in water? Okay, so their dissociation reaction can be written as here. So you have your solid precipitate dissociating into ions. So what are the ions that we can form from this one? Of course, that is copper 2 plus and 2 moles of hydroxide ions. Okay, so that is the dissociation for your sparingly soluble substance or your precipitate. Okay, so that is the reaction. Then we're going to make an ice table. Since our precipitate is in the solid form, we are not going to write any information about that. Okay, so initially, we do not have copper ions in our solution unless stated otherwise, but the problem doesn't tell us that we have concentration for copper 2 plus, so this is 0. For hydroxide, still the same, 0. Okay, so about the change, so since we do not have any concentrations on the product side, it means the reaction or the copper hydroxide should dissociate. Okay, so since the coefficient of copper here is 1, so that is positive x. For the hydroxide, that is the coefficient is 2, so that is positive 2x. Okay, so at equilibrium, that is 0 plus x, 0 plus 2x, 2x. So KSP, or the equilibrium constant for sparingly soluble substances, is equal to x times 2x raised to 2. Okay, so how are we able to get that? Remember, KSP is equals to the concentration of copper 2 plus raised to the coefficient, and the concentration of hydroxide raised to its coefficient 2. The concentration of hydroxide is 2x, so we place it here. Okay, so that's the idea. So to solve for the molar solubility, according to the discussion earlier, that is just equal to the concentration of the dissociated metal. The concentration of the dissociated metal is x, so all we have to do for this problem is to solve for the value of x. So we have to simplify this anyway. This is 2.2 times 10 raised to negative 20 equals to x times 4x squared. Okay, multiplying this by x, we get 4x cubed. Okay, solving for x, that is the cube root of 2.2 times 10 raised to negative 20 divided by 4. The molar solubility is then equal to the molar solubility is equal to 1.77 times 10 raised to negative 7 molar. So this is the answer. How about the pH? Okay, so since we have a value for x, okay, so this is the molar solubility. Since we already have value for x, we're going to obtain the equilibrium concentration of OH, which is just 2x. So the concentration of OH is equals to 2x, which is 3.53 times 10 raised to negative 7 molar. Okay. To solve for the pH, we can use the equation POH is equals to negative log of OH and pH plus POH is equals to 14. So we're going to use the two equations. Solving for POH, that's the negative log of 3.53 times 10 raised to negative 7. I'm not going to include the unit. So that's POH equals 6.45. Okay, so to solve for pH, we're just going to rewrite this equation. So pH is equals to POH. No. So pH is equals to 14 minus POH. That's 14 minus 6.45. The pH is equals to 7.55. So that is the final answer.